If you are watching this video, then let me begin by saying first, congratulations. You have been called upon by the field of chemistry to do a mole equation, and today is your first official day of training.
Can I do a mole equation now, Jackson?
Oh no, you have a lot to learn before you are ready to successfully complete a mole equation. You are about to use one of the most important universal measurements in chemistry. Emilio Avogadro was the creator of the mole. Using molecular theory, he used the number 6.02 times 10 to the 23rd to convert a number of particles of an element into a mole. A mole is a universal measurement for a certain amount of an element or compound. All of this might be overwhelming, right? We haven't even gotten started. Let's see if you have what it takes to do a mole equation. You seem to have the confidence, and you seem eager and ready to work, and an attitude that says, "Look out, world, here I come." That's not how everybody who tries to do a mole equation is. Look at this bad example of someone trying to do a molar equation. You can't solve a mole equation before understanding the mole chart.
The mole chart?
Yes, the mole chart. It shows you how to get to moles from whatever measurement you are in now.
The molar map is a graphical representation of an algorithm that compares molar mass, number of particles in a mole, and factors from balanced equations or other formulas. So let's say you want to get from particles to moles. As shown in the map, to get from particles to moles, you need to go through Avogadro's number, 6.02 times 10 to the 23. Or if you want to get from moles to liters, you need to use the number 22.4. Or from grams to moles, you would have to go to the periodic table and find the molar mass of your element. In all, it visualizes the steps you need to take to solve a mole equation.
Oh, the mole chart. I get it.
Here's a typical measurement. Using the mole chart, maybe we can figure out how to get to moles. If you start with grams, will you use A, 6.02 times 10 to the 23rd, B, 22.4, or C, the periodic table?
The periodic table.
Yeah, man, you got it.
The mole chart never lets us down. I bet now you think you're ready to solve a mole equation.
Can I do a mole equation now?
Whoa, not so fast there. We haven't even talked about how to set up an equation.
The mole equation, you get the value you have and put it up front. And then you want to get rid of that value, so you put that on the bottom. And the value you want to get to is a mole, so you put that on top. And you repeat this process until you get to what you want. So you put that mole on the bottom again because you don't want that anymore. And you want to get the particles, so you use Avogadro's number and put that on top. And then you multiply everything on top and divide by the bottom. And voila, you solved your mole equation.
Here's an example of a bad chemist's molar equation. Do you think you're ready to solve a mole equation now?
Yeah.
Well, you're wrong.
Oh.
You haven't even learned about the real-world practical aspect of moles. Here's a copper penny. Using your mole equation and a few measurements, you can now figure out how many moles of copper this is using a molar equation.
One eternity later.
Now that you know how to set up a molar equation and everything about the mole, it's time for the moment you've been waiting for. Solving a mole equation. So are you ready to solve your mole equation?
Yeah.
Are you sure?
For sure.
Okay, your equation is...